in this question, we have a block moving along, mass m. It has some initial kinetic energy, which they're calling Ki. The two collide, they stick together and slide off together. And this is what they're calling Kf. And so they're looking for the ratio of Kf to Ki, the final to the initial. Now, since we know they stick together, this is an inelastic collision, which means the kinetic energy does not remain the same. Kinetic energy does not remain the same. If it remained the same, it would be the ratio of 1 to 1. But since it doesn't remain the same, we know that is out. So we have a collision going on here. If we want to verify this for ourselves, we have our initial will equal our final, and we have mv, and afterward we have m plus 3m times the new velocity. So we have mv equals 4mv prime. Now the m's cancel out, and we're left with I crossed out the wrong one. We're left with v equals 4v prime, or v prime equals v over 4. So v prime is v over 4. Now let's then look at the kinetic energy afterward. Is 1/2 mv squared. And the mass we have afterward is 4m, and the velocity afterward is v over 4. Quantity squared. So that gives us 2m times v squared over 16. So that is mv squared over 8. That is the final kinetic energy. Well, the initial kinetic energy is 1/2 mv squared, and it's m and it's v. So we want to know the ratio of the final to the initial. So we have 1/8 mv squared to 4/8. So I'm going to convert that to eighths, mv squared. And so this these m's drop, these v squareds drop, and we're left 1/8 to 4/8, which is 1 to 4. Choice D.